In the real world, buildings aren't just made of slabs of concrete, and there's a lot of other interesting construction detail happening in these structures. In this image here, you can see some rebar sticking out of this wall, which is used to reinforce and support the structure. And anytime you look up reference photos of destruction and demolition, you'll typically see a lot of this type of material sticking out of the broken pieces. And here's a close-up view of what that rebar really looks like. Generally, we don't see this close to it, so it doesn't have to be that detailed. Normally, we just use some interesting shaped tubes that are instanced around on our geometry, but it's still helpful to know what this really looks like. Sometimes you'll also see metal mesh, like in this image here, and it's less common to add this to destruction shots, but if you have an opportunity to add this to any of your shots, it can look very cool. For example, in my shot, there's one little clustered together fractured section of my geometry that kind of forms this C shape in here, and I didn't really spend the time to add in metal mesh in the middle there because that's mostly covered up by dust anyway, but that's one example of an area where it could be really cool, if you see it clearly, to have some metal mesh in the middle of that C shape. It can really help to justify why this fracture shape has been formed. If you look at more references of destruction and demolition, you'll see tons and tons of other layers of detail in here, and typically the effects department doesn't add this much detail to a destruction shot. Oftentimes, if you need this much, another department will set dress some of that in, or it'll be painted in 2D, but you can feel free to add as many layers as you would like to your simulation. Generally, in effects, we'll just add in these interesting bits of rebar sticking out of the broken pieces, although you can feel free to develop a library of different types of set dressing geometry you can use in addition to that. But for our purposes, we'll just focus on the types of details that I've circled here. Now you can experiment with different ways of creating the rebar if you'd like, but the way I usually do it is to start by just generating a line down at the origin. I'll zoom in on that and set the direction to point in the Z-axis. And I'll set this to use 6 points instead of the default of 2. And I'll set the length to 3, and I'll hide this creature for the time being. Now I want to make a number of different copies of this rebar that we can scatter across our geometry. So if I want to make 20 copies of that, then I'll add 20 points to scatter this line onto. So I'll start by dropping in an add node, and this will default to add 1 point, but in order to add it, you have to turn on this checkbox here. So now you can see this is creating just 1 point at the origin of your scene. And then you can just use a copy and transform to create some multiple copies of that point. In my case, I'll create 20 different versions of our rebar geometry. And I'm going to want to vary the scale of each of those copies of rebar. So I'll use an attribute randomize and connect the copy to that. And we're going to create a random scale attribute. And the scale is automatically recognized by the copy to point SOP as a non-uniform scale. So if we set a p-scale attribute, that'll scale the line uniformly in every axis, but the scale will be a vector and allow us to just scale the z-axis alone. So on this attribute randomize with the name set to scale, I'll set the min and max to 1 for both x and y, and then in z I'll set that to 0.5 and 1.5. And then I'll connect the line to the first input and our points to the second. And it's not very obvious what the various scales look like at this point. It'll be a bit more obvious once we start adding noise to this, but you can tell just based on these points that it is randomizing those lengths. Now to shape these lines, I'm going to run them individually in a loop. I'll use a for each primitive loop and connect our copy to points to that. And if you display the begin, this is just giving us one of our primitive lines. Then I'll drop in an attribute noise into our loop, and we'll leave the mode on additive, but set that to add to the position attribute. and then display that. And you can see that's pushing our line away from the origin, but if you turn on the center noise option, then it'll remap that noise to be from minus 0.5 to 0.5 instead of 0 to 1, so that'll keep everything still nicely centered around the origin there. Now whenever we're scattering instance geometry onto some other geometry like our fractured pieces, it's helpful to have a root point right at the origin. Because if we try to scatter this rebar piece on there right now, we don't really have an obvious consistent point at which to do the attachment. This is more obvious if we display all of our noisy lines. And these are all following the same path, which we'll fix in a moment. But first, to create that consistent root point, I'm going to add a point wrangle into our loop. And I know that these 2 points on the left here are going to be points 0 and 1, so I can explicitly set a position for those 2 points. So I'll rename that wrangle to root points, and then I'll check if the point num is equal to 0, and if so, explicitly set that position to 0, 0, and minus 0.5 in Z, and if it's point number 1, it'll be right at the origin at 0, 0, 0. So this will give us that nice consistent point of attachment for all of the pieces, but we still want to make this noise unique for each piece of rebar. Now you could set up an offset attribute on the points to be recognized by the attribute noise, or you could control that offset based on the iteration number of the loop, but I find it a bit easier to just use connectivity to create a class attribute. I'll change that connectivity type to primitive, and then in our attribute noise, I'll query that class attribute in the offset here. We can just look up the primitive attribute from input 0 for prim number 0 and the class attribute, and since that's just an integer, we can add a 0 at the end there. And then I'll copy that prim expression and paste the same thing in for y and z. So if the class attribute is 2 for a line, it'll get an offset of 2 in each axis. And then if we look at the end of that loop, you can see all of our lines are getting a unique noise. Now these lines are currently looking a bit low res and jagged, but if you add a subdivide after the loop, that will add some resolution and smooth them out. Just one subdivision should be fine for this. We don't want the rebar to be too high res, because we don't want the caches to be too terribly heavy or the renders, and we're not going to be looking at these rebar pieces super close up for our shot. Now at this point, you can play around with the attribute noise settings to dial in the exact shapes of those rebar pieces. In particular, you'll want to adjust the amplitude here. In my case, I wanted to increase that a bit in Y and Z, but I didn't want to increase it in X because I like having it slightly flatter on one axis in case we need to ever tuck this rebar geometry into an adjacent piece of geometry. Then having some axis that's consistently not a largely varied noise could potentially make that easier. For this shot, I don't think it really makes a difference, but that's how I've set it up in the past. You can also experiment with the different noise types to get some different shapes on your rebar, and of course dial in that amplitude to taste, and I think this will work reasonably well for our shot. You could also potentially change the seed on your randomize if you want a different scale distribution. So if you go to the Options tab and just start changing this global seed, you can see all of the results look pretty similar, but it's a little bit different if you want to accurately control exactly how these pieces are distributed. Now once you're happy with the shapes of these lines, you can use a polywire to generate some tubes along those lines. Connect up the subdivide, and we'll add a little bit more resolution by turning the divisions up to 6 and these segments up to 2. Now these normals aren't looking very good, so I'll use a normal sop to generate some better ones. And I'll also transform this in Z a little bit, just because this root point at the origin is kind of in the middle of some of these rebar deformation areas. So just bumping that over by 0.25 will make it slightly more accurate when we scatter the rebar onto our points. Now to finish up building this rebar, we're going to add a path and name attribute. And I'm going to use that connectivity info, but if you look at these class attributes after the polywire, it looks like they all have a value of 0. So to regenerate that class attribute on our poly geometry, I'll create a new connectivity SOP and set the type to primitive. And you can use a wrangle to set the path and name attributes as we've done in the past, or if you prefer, you can use an attribute create SOP. In that case, you'll set 2 attributes. They will both be primitive strings, one of them called path and the other called name. And then in that string parameter, type rebar, underscore, and then class and backticks. Those backticks are important. If we remove them, you'll see that explicitly adds this @class_string within that path. And if we add those back in, you'll see now it's correctly evaluating that class attribute and setting the path and name attributes properly. Now we can add an attribute delete and remove that class attribute because we don't need it anymore. And we can also remove this unnecessary scale attribute from the points. And now that we've verified that we don't have any unnecessary attributes left over, we can add our pack, turn on pack by name, can turn off this path attribute, and then we'll transfer our name and path from our underlying geometry. And then we'll create a null and call this out rebar. After our rebar pieces are packed, you can add a point jitter if you want to see them a bit more clearly and not stacked up on top of each other. And if you want to, you could continue to adjust the shapes with them expanded out like this, if that makes it easier for you to art direct all of those shapes. And if you want to, you can cache it just before this null. I didn't bother though because this is a very fast thing for Houdini to compute, and it should be totally fine to scatter these live generated rebar pieces on your geometry.